Hi guys, welcome to Learn Electronics Repair and another video sponsored by PCBWay. PCBWay are a manufacturer of premium quality circuit boards. They have a service suitable for both home hobbyists and dabblers and also those who want to make larger production runs of PCBs. You can order unpopulated boards like these ones. You can also order populated boards. It's entirely up to you whether you have your PCBs fully or partially populated. The service is very flexible and it's also inexpensive. The great thing about PCBWay is that they have a shared project section, which we can see here. So let's just take a quick look at this. There are many projects on here. These are projects that people have uploaded. They cover all sorts of things from test equipment to games related, as you can see here, all sorts of things, anything you could imagine. But the best thing with the shared projects, if you could imagine something that somebody else hasn't, or just imagine something better. So you can upload your own projects on here, and if you do that, you will then get a 10% commission from any PCBs that are sold. So this is a great way of getting your idea out there without having to worry about stocking PCBs, about postage or anything like that. PCB will do it all for you and then give you a nice 10% commission. And the PCBs we're looking at today will be on this shared project. They're not there right now, but a couple of days while I just sort all the files out and we will get them on there for you. So let me show you what we have here. This is a PCB that I initially imagined, and Detlef, my friend from Det Build Stuff, nice channel. Oh, congratulations Det on over 1,000 subscribers. Well done. Nobody would deserve that more than yourself. Guys, go take a look, give Det a thumbs up, and we can also give him a thumbs up for this. So this basically is a HDMI breakout board. What we have here are two HDMI sockets in and out. These are all the various signals. Okay. And these areas are actually just uncommitted seat of holes, we will call them. So these are just if you want to stick any components and do things yourself. Now, the reason you might want to do things yourself will hopefully become evident in this video. I'll show you one of these which I've populated, and here it is. So all I needed to do with this was to solder on the two HDMI connectors. If you don't feel up to that, if you order them, you can get PCBWay to do this for you. But given the fact you get 5 PCBs for $5 plus shipping, and if you use the discount code on this video, by the way, if you're a new customer to PCBWay, you get $5 off your order. So in actual fact, it just costs you the shipping, which is about another $5 depending on where you are in the world and how long you want to wait for your PCBs. Yes, there are also express options for postage at a higher price, okay, but I'm a cheapskate, I use the cheap one. So here is the one which I populated, two HDMI connectors, 4 rows of headers, okay, and these are just jumpers, which are actually just salvage ones off old motherboards. I've put them in different colours just out of interest, so we can see here that we have the data lines plus and minus. You can see them all down here, okay. This is actually the video and audio data. We have clock shield and clock. This is your data clock. These are 2 pins. All these mean various things. And by the way, these signals, I made 2 videos all about HDMI. So I'll actually link them. I won't go through all the signals again. You can see everything you need to know there. But I put a couple of green coloured ones here for CEC and reserved. Grey for SCL and SDA. This is serial data, ground, 5 volts. Hot plug det. This is not Detlef, by the way. This pin is called hot plug detect, and this is how a device knows when a HDMI cable is inserted or not. So without these jumpers on, these two are basically open circuit. There's no connection between the two. And you can connect or disconnect any of the pins that you wish. You can also probe. There's either side of the jumper. If you remove a jumper, you can then probe individually either socket so you can look at what's on there. Okay, so that's basically a populated board. Let's connect one of these up and have a look at the signals we can see on here, and then I want to talk about how we can use this. I have some really crazy ideas, or at least my friends tell me they are a bit crazy, but I want to know if you guys think they're crazy, because I've got some interesting ideas to do with HDMI and how possibly we can repair faults which are irreparable. Okay, we'll have a look at these and then we'll talk about that a little bit later in this video. Well guys, we're ready to go. So on here you can see that's the screen from my test PC. So my test PC is just running, sitting there on a desktop, nothing going on at the moment. Okay, that's connecting via here. And I've attached two oscilloscope probes. So just looking at this clearly now, we have clock minus, clock shield and clock plus. Okay, so clock plus and minus is your system clock, which I believe is 100 megahertz on these. Then we have TMD. So this is the data 0 minus, data 0 shield, data 0 plus, just under that green wire there. Okay, then we have the data 1 minus, the shield, the 1 plus, and the 2 minus, the shield, and the 2 plus. So basically the HDMI, it's like PCIe. All this stuff is LVDS. So the signals that it sends down the cable, each signal uses a pair of wires plus a shield. But the signal that is received at the other end is the difference between the two plus and minus data lines. So if data line 0 plus is higher than data line 0 minus, that's one logic state. Let's say it's a logic 1, I don't know exactly. And if it's the other way around, with data line 0 minus higher than plus, that's a logic 0, or at least it's the opposite state. So the first thing that may surprise you, depending on what you expected and how easily surprised you are, is that when the video device is like this, so I can move my mouse around, but now I'm doing nothing's happening on the screen there, is that if I now just pause the scope, so you can see the data 0 minus and data 0 plus there, they're kind of like a bit all over the place. There's no real pattern between the two. Do you see that? That is effectively noise. Now, the reason we see this, and this is what may have surprised you, is when you have a picture on the screen like that and nothing's changing, the device sending the video isn't actually sending any signal. It sends that picture once, and that's held in a buffer inside the monitor, so it's not actually sending any data to maintain that image. And this is why we kind of just get this noise. So what we're going to do now is just run a program. I said benchmark program. So something's happening now. Let's see what happens now on our data 0 plus and minus. Well, can you see straight away that there's like a signal in there? Yeah, you can see the noise, but can you see there's a signal in there? Let's hold it. There. Now that is LVDS. So you can see we have the two signals. I'll superimpose them, and they're crossing over. So effectively, the yellow one is the data plus and the blue one is the data minus, and that is your data as these cross over. So in this instance, you can see this one is below this one, and then this one is above that one, and so on. Yeah, that is data. And that's how LVDS actually works. And because it uses the difference between the two signals the noise isn't actually relevant to it, because if there's a spike, both the blue and the yellow will go up together or go down together. You can see these are not on a level line, they're kind of like wandering around. That is noise in the signal, but it doesn't actually affect the integrity of the data. Look, I've caught one of the big peaks there, but you can see again they're crossing over, they're out of phase. Yeah, that's how LVDS works. Okay, now I've moved the wires. I'm actually on the clock. This is the data clock or system clock. And you can see on the scope now that it's much more stable, if like. We have the same frequency, but we don't have the same data. So the two signals now are a lot more symmetrical on each other. Yeah, you can see them. Okay. But once again, you can see they're in this anti-phase. Okay. You can also see now I've stopped the demo program from running, so we have a static screen again. The clock is still running, so that stays there all the time. It's only the data that appears when the image is changing. Okay. Now, this brings me to some interesting ideas, and this is why I want to chat to you guys about something which I've had in mind for a while. I've never tried this, and maybe this is crazy, but let me tell you what I'm thinking. We can see then that with the LVDS we have two signals, a plus and a minus. I think we can probably call them inverted and non-inverted in the same nomenclature as an op-amp. Okay, and the two signals basically are in antiphase. We've seen that on the oscilloscope. We've seen ourselves that we get signals in an antiphase like so. Okay, and this is how the data is transmitted. So we have a sender chip, a transmitter. This is where we put our data, square waves, in the source, the video source, whatever's sending the information, and we have two outputs. Okay, the non-inverted and the inverting output, and that is your LVDS, which is low voltage differential, difference between them, differential signal. Okay, and then at the other end we have the receiver via our long piece of wire, long cable it could be, or it could just be on the same circuit board. HDMI uses this, we've just seen this, what I mentioned before. PCIe also uses this, SATA also uses this, so lots of forms of data, USB, all the ones you can think of basically use this system. Okay, the other end is our receiver, and we then, coming out of here, is our data again. So that's how it actually works. This is on here, we've just seen where this is, comparing the two signals. Now, the crazy thing I thought of is that sometimes you can have a device where one of these inputs is faulty, basically. Could be on a graphics card, if we're talking about PCIe. Could be a problem somewhere on one of these lines, on something like a games console, something like that, or some device you can't easily replace. And what I wondered is, how mad is this, that basically if we receive this and we put a voltage here, resistive voltage divider, and we set a voltage here that is halfway between the amplitude of the signal, that even if one of these signals is missing, the other one will cross over the halfway point, which is coming from here. I just drew it in a strange way. Shall I draw it better? Yes. I think a lot of you figured out what I'm talking about here. Okay. This will give us a DC level and the signal coming in on here, crossing over it. And this should actually then, in my mind at least, pick up the signal and give us the data out. Now we know there's a lot of noise, we've seen all that noise, but if you put this close enough to the sending device, very close to its short bit of cable, you'd reduce that noise massively. I was probably seeing a lot of noise because of this board, it's not shielded, yeah. I was picking up all sorts of noise, but the LVDS was handling it. I think with shielded wires and much closer, you could probably get away with this, and you could probably actually make this work. Yeah, that's the first thing I thought. The second thing I thought is that not only do we have the data channel 0, 1, 2 on our HDMI, we have 16 channels or lanes on the PCIe. In the full implementation, we also have the clock, plus minus. This same trick would work if one of these was missing. You could regenerate it, because once you've effectively done this, botched it if you like, you can feed this now into another one of these chips and come back out with the original signal down your long cable. You get the idea. So you're just regenerating the LVDS with both signals working. The other thought, and this was maybe even crazier, is that we can see that the signals are sort of doing this, carrying the data. And we've seen the clock signal as well. And the clock must effectively tell the receiving device to read the data at a certain point. And it's saying, okay, are the two signals this positive, this negative, or are the two signals this one positive and this one negative? So the clock effectively must tell the receiving device, probably on a rising or falling edge, maybe on both, read the data now. Read the data now. I don't know if it uses both edges or not, but that's not really relevant. But because the data is continually crossing over like this, would it be possible to detect the point where the two signals are the same and use that to regenerate a clock that's missing altogether because of a fault in the sending device? Yeah, so effectively you know exactly when these two cross. You then generate a clock pulse of a width suitable so the next edge coincides with the point where you want to read the data in the waveform. Wow. I talked about this with Carlos and Det, and Det says, Rich, you're crazy, man, but I think that might work. Yeah, Carlos, he says, Rich, I think you're brilliant, it might work, but I don't know. So part of the reason why we built this is so we can use these areas to effectively add a little daughter board, if you like, with receivers and transmitters, and kind of like take one of these links out so we lose the signal, and then see whether from here to here we can regenerate the signal on the board. Yeah, putting a metal can for shielding, probably a good idea, but that's what we had in mind when we designed this. Not only is it a useful tool to diagnose what's happening with the HDMI, we think we may be able to regenerate signals as well. What do you guys think? To do that, we need chips like these from Texas Instruments. We can buy these. You can see the kind of way it's wired up. You can see the description I was using of how this actually works. So all the information is here. These are little SOT23, little, if I can find them. Yeah, kind of like those type of devices. That's not the one, but they come in that package. In fact, they come in a few different packages, as we've seen. Okay, so that's a possibility, and we could buy some of them and see what happens, I think. And one other thing we thought about with using this board, we can disconnect the signals from the input to the output. We can connect this to like some sort of microcontroller device. We're wondering whether we can make a little device or modify this. Again, we can add daughter boards from here so that we can basically poll or measure all the inputs on a HDMI socket, on a monitor or a sending device like a graphics card, and we can effectively tell whether the HDMI port on the other device is electrically good. Not saying it's sending any data out, but whether there is a physical connection from that to the circuitry on the other end. Do we have any shorts from any of the lines to ground? Are any of them open? That sort of thing. A kind of like go, no-go test for a HDMI port, for example, on a GPU. So that's the other thing we had in mind we might be able to do with this. So in actual fact, you're going to see this again because there's lots of things I think we can do. And I think after you guys have added your thoughts, there's going to be lots more we can do with this. Or maybe it's all a pipe dream. I'd just like to say once again, thank you very much to PCBWay for making this sort of project possible. Thanks to you guys in advance because I know you're going to have a lot of suggestions about this. And thanks to Detlef and Carlos already for their input on this project. I'll get the shared project set up on PCBWay very soon for you guys. I'll put a comment on the video, pinned comment when that is ready. And then if you guys want to play around with some of these, you can easily get them yourselves. Okay, thanks for watching. Hope you enjoyed that. And I look forward to seeing you all soon again on another Learning Electronics Repair video. Ciao for now, guys.